Hello, this is another video from the battery lab. We've built 327 batteries, and this one is quite unusual. So I have to give this one an honorable mention, and I think this battery actually has a place in the world. We've built batteries that have very high power for a very short time, batteries that have very low power for a very long time. Like the battery I showed in my last video, we built batteries that have a lot of power for a long time. This battery shows some really promising qualities. Number one, no matter how much power you put in it, you can't hurt it. The more power you put in it, the more it self-protects itself. So you can't burn it out. Number two, it's one of those batteries that will go for about 1 million charges, because the chemistry and the plates are some of those, sorry about that, are some of those things that just don't wear out. Now, this battery, I'm going to show it to you. It's been charging on the Variac all night. And we're going to turn that switch off. You're going to hear a distinctive click. That's when we turn it off. But we're going to really watch the motor and the volt gauge. That's the most important thing. I got to focus in on this. Sorry about this, folks. Just getting used to this camera. Okay, I'm going to tighten everything down here. Okay, so we got 256 volts. It's been charging for 8 hours. What you're going to see is not very impressive at first. We're going to turn it off. And this battery self-discharges in about an hour. But let's watch the power output. While it's going down, let's power something. We're going to power this motor. Oh, that one's not making contact. That's a 1/2 amp motor. And we're already down to 190, 180. We've built batteries that do much better than this. But that's not the surprise. Let's let this run all the way down and show you the surprise. Now keep in mind, this is only a single plate battery. So we're talking about the 1 to 2 volt range. And the plates are 7 by 10 inches. And there's only one set of plates. It's already down to 1500. And we'll just maybe wait for it to hit 800. Does hold quite a bit of power, but not as much as other batteries we've built here. But what makes this an interesting battery is how fast it can take on a charge. Now, I thought this would be interesting to use in the wind turbine industry. And I'll tell you why. Wind turbines usually suffer from a problem where they're making too many volts and not enough amps. So people go out and buy expensive buck boost inverters, some of them from popular companies up in Washington State, which I'm not going to mention on camera. But what these things do is they turn voltage into amperage, or amperage into voltage. And in a lot of cases you can get 75% more power out of a wind turbine. And I had a thought about this battery. Let me let it run down, and I'll show you what I had in mind and what we've done and how it worked. let's keep going. We're down to 800. The wheel is turning slower and slower. The battery's down to 700. Okay. Now this is what I really wanted to show you. How fast this battery takes a charge. Yeah, we're going to take it. We're going to take this off. Now watch. All I'm going to do, turn on the charger, and we're going to take it up to 2 volts for. Oh, making sparks here. We are not making contact somewhere. I think it's at this terminal. Hold on. Okay, we're going to take it to 2 volts for a few seconds, turn it off, and we're going to turn the motor back on. All we did is give it a pop of power. Okay, let's turn it back on. And we're going to charge it now for 5 seconds. Usually we charge around, turn it back off, and we're back up to full power. That's how fast this thing recharges. But look, it dies just as fast. You hear that? Instant charge, instant death. Are you starting to see the picture here? Do we have a battery? I don't think so. I think we've created something else, discovered something else. Here we go again. Turn on the charger, take it up to 2 volts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Turn the power off, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 seconds of power. This thing has a 1-to-1 ratio. If you put 60 seconds of power on, it'll run this motor for 60 seconds. This is very strange. I've never seen this before. I think you people know what I'm getting at. What we've actually developed is a liquid capacitor. Now, I mean not liquid, but let's call it aqueous. Water-based capacitor. Now, the first company to build water-based capacitors, I believe they built them in the 1920s. I forget the name of the company. And I think Mallory, who now is the owner of Duracell, also built dry aluminum capacitors around the same time, about 1925. And then another company, I forget the name of them right now, in around the mid-1920s, built a wet aluminum capacitor, which is good for 4 farads. And the thing was humongous. That was a water capacitor. And then from then on, Mallory took over making dry capacitors, and ever since 1925, all capacitors have been dry. No water in them. This is behaving much like a supercapacitor. A supercapacitor has a hell of a lot of, carries a lot of farads of electricity, and it's rechargeable endlessly. Okay, here we've had it on for about a minute. Let's see how much power we got. There we are, back up to really high power level. See if we can get 60 seconds runtime out of it. So we got 60 seconds in, and let's see if we get 60 seconds out. We just might. Wow, it's doing pretty good actually. But when it dies, it's going to die real fast like a capacitor. Now our idea was to put this on a wind turbine. Wind turbines, they go up in speed, they go down in speed, and a lead acid battery, it can't take too much additional voltage and turn it into amperage, so it's kind of wasting power. But if you put one of these capacitors, perhaps a 7-cell version of this, ahead of a battery with a diode, you would in essence have a hell of a buck-boost inverter. The wind turbine would charge this up, take all the energy from a wind gust, store it in this capacitor, and then slowly pass it off to the battery. You would have really just about doubled the output of a wind turbine by doing this, because this type of capacitor isn't slowed down by amperage. You can put a really high amp load in it, and it'll just suck it all up like a sponge. Now, it doesn't hold energy long. If we turn it off, this battery will be dead in about 3 hours. But I'm talking about actively putting capacitive voltage into a turbine going through one of these. And this is an interesting setup. We're using iron plates, and we're using passive chemicals that are protecting the anode passively. Okay, there we're back down to some crazy low voltage. Looks like the contact fell back off the electrode. Okay, down to 0.4 volts. Now watch this. This is crazy. Now let's simulate a wind gust. A real fast wind. Wait a minute. Whoa. Sorry. Let me take this off. Am I still online here? Okay. Let's simulate a wind gust. About 50 miles an hour. Here we go. We're going to turn this up to 5 volts for 5 seconds. Here's a big wind gust. Now watch how much. I'm going to do this just for a little while. I'm going to count it down. 6 volts. 1, 2, 3, 4, 5, 6, 7. And we turn off. Now that was 7 seconds. Watch this. It sucked up every bit of that high voltage power. So we have a 5-second burst of power, and now it's going to dissipate that power over the course of about 30 to 40 seconds. I have to flip this switch so it doesn't go into automatic turn off. Oh, it's still going. That was 7 volts for 5 seconds. And this thing is still going. It's been about 40 seconds now. It's still up to 1.3 volts. It's dying very rapidly right now. I think this battery got passed up by a lot of electrochemists because, frankly, they didn't think it made a great battery, and I don't think so either. But its use as a wet, aqueous, cheap, low-cost capacitor can't be underestimated. I mean, you can't dismiss a technology like this. Here we go again. We're going to go back on. I'm going to turn the motor off. We're going to turn this variac back on. Here we go. Turn it on. We're going to go up to, let's go up to 8 volts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It was actually about 5 seconds. I counted too fast. Here we go. That's a 5-second burst. It caught all the energy. So 5 seconds at a higher voltage. gives you about a minute to a minute and a half at about a quarter of the original voltage. This is very highly efficient. Not a good battery, but an amazing capacitor. I've never seen anything like this in 327 tests. None of the batteries has behaved like this. Very strange behavior. Like I said, we've been doing this for about 4 weeks now. Up, down, supercharging it, trying to break it. The plates are in very good shape. Here we go again. We're down to this thing barely spinning. 0.7 volts. We're going to take it offline. Turn the rheostat back on. Give it a jolt of power. 1, 2, 3, 4, 5. That's 6 volts. 5 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It sucked it all up like a sponge. Truly look how fast it dies. Let's watch again how fast it charges. Let's go for another round. Okay. Trying to get both of these in the screen. And it's holding. Once it gets down to about 0.7 volts, it'll sit there and run for hours. It doesn't. Well, this is a really, at this point it's a really good battery. For some reason it'll run for about 8 hours at this speed. And then it's completely dead. Whether you have a motor running on it or not. Here we go, one more boost. Turn this back on. We'll go up to 6 volts for 5 seconds. 1, 2, 3, 4, 5. Turn it off. Let's see how much energy we caught. Up to 2 volts. We went up to 6. And for 5 seconds at 6 volts, we're getting a good minute of run time at higher voltages. Let's see if we can go to one extreme. I'm going to try 10 volts. I don't know if it's going to hold 10 volts, but we'll give it a try. And there it's back at 7 where it likes to be, and it'll keep running for a long time till either the battery dies or time has expired. Okay, let's try going up to 10 volts. I hope it holds it without popping a fuse here. Okay, let's go. Okay, there's 10 volts for 5 seconds. Let's see how long we got here. Yeah, it seemed to like that. Imagine a wind turbine surging into this capacitor. About 7 plates worth would give it 14 volts for a 12 volt battery, and then having that voltage feed into your lead acid or lithium ion, increasing your efficiency up to a very high level. There we go again, we're plateaued at that 700 figure. We'll run for a long time. I probably don't want to bore you by keeping the camera trained on it, but you can see how slowly the voltage is going down now. Okay, that was it. This is battery number 327. Special chemistry battery. We are going to definitely build a product out of this one. Hope you thought this was interesting, folks. I certainly do. Thanks for watching. Have a great day.